Welcome back, everyone, to 11.6 Absolute Convergence and the Ratio Test. Let's get right back into it with an example. So again, we want to determine if the following series is absolutely convergent, conditionally convergent, or divergent. So the first thing I'm going to go ahead and do is apply the ratio test. The ratio test is going to tell us if it's absolutely convergent or not. So again, the ratio test goes a sub n plus 1, so I'm looking at my series, and everywhere I see an n, I plug in an n plus 1, divided by a sub n. We take the absolute value of this, and then we take the limit as n goes to infinity, and we say, hey, what does this approach? So let's go ahead and rewrite this. So I'm going to rewrite this, and instead of dividing by this nasty fraction, let's go ahead and multiply by its reciprocal, because that's a good way to get things to cancel. So again, I have my a sub n plus 1, all this stuff. And now I'm going to be multiplying by the reciprocal. So that is n factorial divided by negative 1 to the n times n squared. And we're going to think about this again in groups, right? We're going to group kind of these like terms and think about the quotients of those. So first of all, let's group these negative 1s together. So everything with a negative 1 to the n plus 1 to the n, stuff like that. Then we're going to group all the stuff, the squareds together. Then we're going to group all the stuff with factorials together. And see, hopefully there's some cancellation, right? So, okay, let's group the negative 1 stuff. So that's going to be negative 1 to the n plus 1 over negative 1 to the n. And then let's go ahead and group the squared stuff next. So n plus 1 squared over n squared. And then let's group the factorial stuff. So n factorial divided by n plus 1 factorial. And remember that n plus 1 factorial is the same thing as n plus 1 times n factorial. So in fact, there's already some cancellation we see. All right, so this is going to be the limit as n goes to infinity, the absolute value. And we can see already with these negative 1s, there's some cancellation that happens, right? There's one more negative 1 in the numerator than there is in the denominator. So those go ahead and cancel out a little bit. And now with all this other stuff, I have n plus 1 squared over n squared times n plus 1. So one of those n plus 1s canceled out. So let's go ahead and take the limit as n goes to infinity of, and well, this is just going to be the absolute value of n plus 1 over n squared, right? Because the absolute value of negative 1 is just 1. Well, these are all positive terms, right? N is a natural number heading towards infinity, so this is all positive. So this limit is going to be 0, right? Because, well, you can use L'Hopital's rule, you can use Math 132, whatever you're comfortable with. Well, this is certainly less than 1, right? So by the ratio test, our series, that is negative 1 to the n times n squared over n factorial, sum from n equals 1 to infinity, is absolutely convergent. All right, let's go ahead and try another example. Determine if the following series are absolutely convergent, conditionally convergent, or divergent. That's the kind of game we're playing these days. This one looks different though. Again, I'm going to try to apply the ratio test. The ratio test is going to tell me, is this thing absolutely convergent or is it divergent, right? So these are some of the results. So let's try the ratio test. So again, I have my a sub n plus 1 divided by a sub n. So 3/5 raised to the n. There we go. And so this is going to be the limit, and we can go ahead and make some cancellations here. Well, the n plus 1 over n can't really do much there, but here we have 3/5 to the n plus 1 over 3/5 to the n, right? So there's one more in the numerator than there is in the denominator. So that's just going to be 3/5. Again, we're taking the absolute value of all of these things, but these things are all positive, right? So the absolute value does nothing. So this is just the limit as n goes to infinity of n plus 1 over n times 3/5. Well, n plus 1 over n, well, that's going towards 1. So this is 1 times 3/5, aka 3/5, and that's less than 1. So by the ratio test, we know that our series right here is absolutely convergent, which is kind of a silly thing to say because our series is all positive, right? So if you took the absolute value, it wouldn't do anything, right? But okay, it is absolutely convergent, certainly. Okay, and now our final example of the section, we're going to go ahead and take the sum of cosine of pi n over 3n, and we want to know, is this thing here absolutely convergent, conditionally convergent, or divergent. And the first thing that's interesting is this cosine of pi n. So I want to know, what is this thing doing? So I'm going to do a table to figure out the first few values. So if I plug in different n's here, I want to know what happens. So n, I'm going to do a table, and cosine of pi n, I guess n0, 1, 2, 3, 4. Actually, yeah, it doesn't really make sense for n to be 0 here. It probably starts at 1. So let me go ahead and change that. N equals 1, 2, 3, 4. And I'll go a few more higher. We can do 5 and 6 and stuff here in a second. So when I plug in 1, well, we have cosine of pi. Cosine of pi is negative 1. When I plug in 2, cosine of 2 pi is 1. When I plug in 3, cosine of 3 pi is negative 1. When I plug in 4, cosine of 4 pi is 1. You can kind of see the pattern here. Now with 5 and 6, we get negative 1, 1. So it turns out cosine of pi n is the exact same function as negative 1 to the n, at least over the natural numbers. So we can go ahead and replace this, right? Cosine of pi n gives me all of the same values as negative 1 raised to the n. So instead of thinking about this series as cosine of pi n, which is confusing, let's go ahead and think about it as negative 1 to the n. Plug that in. So again, let's go ahead and use the ratio test. Ratio test says I need my a sub n plus 1. I need my a sub n. Again, I've been doing so many of these, let's just go ahead and multiply by the reciprocal of a sub n. So this is going to be my 3n over negative 1 to the n. Taking the limit as n goes to infinity. Again, we see some 3's cancel out. There's one more negative 1 in the numerator than there is in the denominator. So this is going to be the absolute value of negative 1 times n over n plus 1. Again, when we take the absolute value of negative 1, though, that's just 1. So we could go ahead and get rid of that. And this is all positive, but okay. As n goes to infinity, again, with Math 132, horizontal asymptote knowledge, or with your L'Hopital's rule, you know that this is equal to 1. So back up here, we're trying to figure out absolutely convergent, conditionally convergent, or divergent. In this case, it shows that it's inconclusive, right? So the ratio test doesn't actually help us. So let's try to think of some other stuff, right? It doesn't say we had to use the ratio test. So let's go ahead and factor out this 1/3, and we can notice, this looks very familiar, right? This negative 1 to the n over n. We saw this at the beginning of the section. So we actually know that this series, the sum from n equals 1 to infinity of negative 1 to the n over n, is convergent by the alternating series test, right? So the limit of the term, absolute value of the terms goes to 0, and it's a decreasing sequence. And yet, when I take the absolute value of this term, we get 1 over n. And so we have the sum of 1 over n is divergent by the p-series test. Again, we've seen exactly this earlier in the section. And so therefore, our series, cosine of 3n over, cosine of pi n over 3n is conditionally convergent. All right, and that's all there is to it here in 11.6. You're now ready to conquer your homework. I'll see you next time in 11.8, Power Series.